Ever wondered if you could just sit back and relax while your car drives you to your destination? Well, the future of self-driving cars is steering towards us at full speed. These automated vehicles, also known as autonomous cars, are on the brink of transforming our daily commutes and long-distance travels. Imagine the convenience of reading a book, catching up on emails, or even taking a nap while your car does all the work. Truly, it's a revolutionary concept. The magic behind these vehicles lies in a fusion of cutting-edge technologies. Advanced sensors, artificial intelligence, and machine learning all work together, creating a car that can see, think, and make decisions on its own. As we speak, engineers are refining these technologies, making self-driving cars safer, more reliable, and more efficient. Hang on tight as we dive into the science behind these fascinating machines. Imagine a car that sees the road better than you do. That's the magic of self-driving cars. Now you might wonder, how does a car see? Well, it's all about sensors and cameras. These are the eyes of a self-driving car, continuously scanning the environment to gather valuable data. They help the car perceive its surroundings, identify objects, and even recognize the intent of other road users. Let's delve a little deeper. A primary sensor used in self-driving cars is the radar. It emits radio waves that bounce off objects in the car's vicinity. The time it takes for these waves to return tells the car how far away an object is. Radars are particularly good at detecting large, metallic objects like other vehicles, and they function well in harsh weather conditions. Next, we have LiDAR, or light detection and ranging sensors. These work similarly to radars, but instead of radio waves, they use pulses of light. LiDAR can create a high-resolution, three-dimensional map of the environment, capturing minute details like the shape of a pedestrian or the edge of a sidewalk. However, they can be less effective in certain weather conditions, such as heavy rain or fog. Finally, we have cameras and computer vision technology. The cameras capture visual data, while computer vision algorithms process this data, identifying objects, lanes, traffic lights, and even reading road signs. This technology is continuously evolving, and it's getting better at understanding complex scenarios and predicting the behavior of other road users. So, we have radars for distance and large object detection, LiDAR for detailed mapping, and cameras for visual recognition. Each has its strengths and weaknesses, but together, they provide a comprehensive perception of the environment. The car's computer system, or brain, uses this data to build a detailed understanding of its surroundings, effectively seeing better than any human driver could. So, our car can see, but how does it make decisions? Let's find out. Driving involves making countless decisions. From deciding when to brake or accelerate, to figuring out the safest path, every decision counts. Now imagine a computer making all these decisions. That's the magic of self-driving cars. Behind this magic is a duo of powerful technologies: machine learning and artificial intelligence, or AI for short. Machine learning is essentially the brain's ability to learn from experience. In the world of self-driving cars, this experience comes from vast amounts of data, collected from sensors, radar, and cameras built into the car. This data includes information about the car's surroundings, like the position of other cars, pedestrians, traffic signs, and even the weather conditions. Now, you may ask, what does the car do with all this data? Well, that's where AI comes into play. AI uses sophisticated algorithms to analyze this data and predict the behavior of other road users. For instance, if a pedestrian is standing at the edge of a sidewalk, the AI might predict that they could step onto the road. Using this prediction, the AI can decide the best course of action, maybe slowing down or changing lanes. But it's not just about predicting what others might do. The AI also has to decide for itself. Should it speed up to make a changing traffic light, or should it slow down? Should it stay in its lane or switch to another? These are complex decisions that the AI makes in a fraction of a second, all while keeping safety as its top priority. So when you see a self-driving car smoothly navigating through traffic, remember that it's not just a machine. It's a marvel of modern technology, constantly learning, predicting, and deciding, all with the goal of getting you from point A to point B safely and efficiently. The car can now see and decide, but how does it act? Stay tuned to find out. Now that our car can make decisions, it's time to put them into action. But how does it do that? let's dive into the fascinating world of the car's control systems. These are the components that translate the decisions of our self-driving car into physical actions. They're the actuators, the doers, the movers and shakers of the autonomous vehicle world. Picture this. The car's sensors feed data to the brain. The brain makes a decision, say, to turn left at the next intersection. Now, this decision needs to be executed. This is where the control systems come into play. First, the car has to determine the appropriate speed for the turn. To do this, it uses its engine control unit, or ECU. The ECU is essentially the car's throttle master, adjusting the engine's output to achieve the desired speed. If the car needs to slow down, the ECU can cut power to the engine, or even engage the brakes if necessary. Speaking of brakes, they're another critical part of the control systems. The car's brain sends a signal to the braking system when it decides to slow down or stop. The braking system then applies the necessary pressure to each wheel, slowing the car down smoothly and safely. And finally, we have the steering. The car's brain communicates with the steering system to turn the wheels in the desired direction. It determines how much to turn the wheel based on factors like speed, road conditions, and the angle of the turn. The steering system then executes this command, guiding the car around the turn. In essence, the control systems are the car's muscles, taking the brain's decisions and turning them into physical actions. They're what make the car move, stop, and turn, executing each decision with precision and accuracy. These systems, working in harmony, allow the car to navigate the world around it, making thousands of decisions and actions every minute. The result? A car that not only sees and decides but also acts, a true marvel of modern technology. So now we have a car that can see, decide, and act. But is it safe? Safety is a major concern when it comes to self-driving cars. How can we trust a machine with our lives? Indeed, this is a question that has puzzled engineers, ethicists, and the general public alike. The answer lies in a combination of advanced technology and stringent safety protocols. Self-driving cars are designed with a multitude of safety features, from LiDAR sensors that create a three-dimensional map of the environment to predictive algorithms that anticipate potential hazards. These cars are also programmed to obey traffic rules to the letter, eliminating human errors such as speeding or distracted driving. But the safety of self-driving cars isn't just about preventing accidents. It's also about how these vehicles react when an accident is unavoidable. This brings us to the ethical considerations involved in programming a car to make life or death decisions. Suppose a self-driving car is faced with a scenario where it must either swerve into a crowd to avoid a collision or stay on course and risk the passenger's life. How should the car be programmed to respond? This is a complex issue and there's no easy answer. Some argue that the car should prioritize the passenger's life since they are the ones who purchased and trusted the vehicle. Others believe that the car should minimize overall harm, even if it means putting the passenger at risk. These ethical dilemmas highlight the challenges of integrating autonomous vehicles into our society. However, it's important to remember that these scenarios are extremely rare. The primary goal of self-driving cars is to prevent such situations from arising in the first place. With their advanced sensors and algorithms, these cars can detect and react to potential hazards much faster than a human driver. In addition, self-driving cars are continually learning and improving. As more of these vehicles hit the road, they share their experiences and data with each other, helping to enhance their overall performance and safety. While self-driving cars may not be perfect, they hold the promise of a safer and more efficient future. Indeed, by eliminating human error, improving traffic flow, and potentially saving millions of lives, the rise of self-driving cars could herald a new era in transportation. The journey of self-driving cars is just beginning. What does the future hold? As we venture into the unknown, we imagine a world where self-driving cars are the norm, not the exception. Imagine the potential benefits: decreased traffic congestion, lower carbon emissions, and a world where no one ever has to worry about finding a parking space again. But this future also comes with its own set of challenges. As these autonomous vehicles become more prevalent, questions arise. How will they coexist with human drivers? How will we address the ethical dilemmas posed by their programming? And perhaps most importantly, how will we ensure the safety of everyone on the road? The road to self-driving cars is full of twists and turns, but one thing is certain: the ride is going to be exciting. As we navigate this new frontier in transportation, we'll be on the edge of our seats, watching as science fiction becomes reality.